How do you build an empire, measure trade, and engineer aqueducts without the number 0? Before the Hindu-Arabic decimal system became the global standard, European mathematics relied entirely on a numbering system that lacked any concept of a placeholder. Instead of using digits in a positional grid, the Romans used just 7 symbols. These letters act as physical blocks whose values are simply tallied up. To keep track of their values from largest to smallest, you can use the phrase medical Xavier. Reading from left to right, this gives you 1,000, 500, 100, 50, 10, 5, and 1. There are 2 main rules for writing numbers this way. First, you add the values together reading left to right. 10 plus 10 plus 5 plus 1 plus 1 equals 27. Second, you can never repeat a symbol more than 3 times in a row. Because you are physically stacking values rather than sorting digits into ones or tens columns, the core strategy for constructing a number changes. The 3 repeat limit creates a practical problem. If you can't write 4 i's in a row, how do you write the number 4? The solution is subtractive notation. When a smaller symbol is placed directly before a larger one, you subtract it. So an I before a V is 5 minus 1, giving us 4. This rule comes with strict boundaries. The symbols for numbers starting with 5, V, L, and D, can never be subtracted. Additionally, a symbol can only be subtracted from the next 2 higher symbols. That means there are exactly and only 6 legal combinations for subtraction in the entire system. This prevents a common mistake. You might think the number 49 should be written as IL, or 50 minus 1, but I can only be subtracted from V and X. To write 49 correctly, you have to build it out of valid subtractive pairs, 40 and 9, XL and IX. Without these strict mathematical constraints, a single string of letters could be read multiple ways. These rules guarantee every Roman numeral has exactly 1 correct interpretation. When converting modern base 10 numbers into Roman numerals, people often mistakenly try to translate them sequentially as they speak them. If you hear 1984, it is tempting to translate a 19 and then an 84. To do this accurately, you need to use the syllable method. You take your base 10 number and break it apart by place value into thousands, hundreds, tens, and ones. 1,000 is M, 900 is CM, 80 is LXXX, 4 is IV. Then you snap those pieces together. Let's test this out right now. Pause the video and try translating the numbers 1967 and 403 using this exact method. Here are the solutions. 1967 splits into 1,000, 900, 60, and 7, M, CM, LX, VII. 403 splits into 403, CD, III. Chunking a number by place value is the only reliable way to accurately bridge the gap between our modern positional system and the Roman additive system. Converting numbers is one thing, but doing actual math with them presents a new hurdle. Standard calculation techniques like carrying a 1 or borrowing from the tens column rely completely on zeros and place values, which do not exist here. To add Roman numerals directly, we will use a 4-step process. Step 1 is uncoupling. Let's add CX24 and CXL. First, we take any subtractive pairs like IV and XL and expand them into their additive forms, 4 I's and 4 X's. Step 2 is mashing and sorting. We combine all the expanded symbols from both numbers into one long string, sorted from largest to smallest. Step 3 is upgrading. We look for groups of symbols that can be condensed into their next highest value. We have 6 X's, so we take 5 of them and transform them into a single L. Step 4 brings us back to our formatting rules. We reapply subtractive pairs to clean up the answer. The 4 I's at the end group together and morph back into IV, giving us our final sum, CCLXV. This expand and condense workflow completely replaces standard calculation. It uniquely allows you to solve math problems purely by grouping physical symbols, bypassing the need for abstract numeric values. Let's test these rules with a bug bounty challenge. Look at the string MIMCVIMC. This is invalid syntax. Highlighting where smaller symbols precede larger ones reveals violations. You cannot subtract I or V from M. Tallying the intended values gives 1909. To write that legally, we reorganize into proper syllables. 1,000 is M, 900 is CM, and 9 is IX. The correct string is MCMIX. Because arithmetic was so cumbersome, this system was eventually replaced by Hindu-Arabic numerals for calculation. But as a tallying and labeling tool, its permanence means we still read these symbols today on stone monuments, historical documents, and clock faces. This graphic shows the core operational rules. You have 7 base symbols memorized by the phrase Medica Xavier, a strict 3-repeat limit, the syllable breakdown method for translation, and exactly 6 valid subtractive pairs, keeping in mind that V, L, and D are never subtracted. Mastering this logic puzzle highlights the invisible conveniences of our modern system. Seeing the amount of weight the number 0 carries clarifies exactly why it is the essential building block of advanced mathematics.